Hi everybody, let's talk about oceanic continental destructive plate boundaries. So this occurs when one oceanic and one continental plate move towards each other because of underlying converging convection currents. Remember, convection currents being really important in describing any type of plate boundaries at all. And what happens here is your oceanic plate, because it is much more denser than your continental plate, your oceanic plate is the one subducting. So let's visualize it in a diagram. Let's draw a thick continental crust, and let's draw a thin subducting oceanic crust. And it goes down like that. Then let's draw our convection currents and our movements of the plate, and also an ocean up here if you want. So this is our rough sketch of a oceanic continental destructive plate boundary. Now let's move on to our landforms. So our Benioff zone is over here. Is the area or the point or the zone of a deep earthquake foci, because it's the point of collision between the two plates. So that's where your pressure is built up, where it's getting all the tension and where it's releasing all the tension, and therefore your earthquakes are happening. The subduction zone is the point of subduction. Your accretionary wedge or your accretionary prism, it's over here, kind of like an extension of the crust. It occurs when some parts of the crust or the old crust was both of them were scraped away off of each other, and they ended up depositing on the sea floor in the ocean, and that forms a trench over here, a deep depression in the ocean floor called an ocean trench. The next thing happens when you have the melting of your subducted plate, and remember the oceanic crust, they have really explosive, really gaseous material, silica. So when it mixes with the mantle, it becomes much less denser. So it starts to rise up into the crust, into the lithosphere, and it creates a magma chamber. Now, two things can happen here. Either a batholith or a volcano can form. Batholiths are when your magma chamber is filled with magma. However, it doesn't really erupt. It just stays there. It cools down and solidifies into igneous rock. And eventually, your crust will, some of them will erode until it exposes the part of the igneous rock, and it leaves an imprint. It leaves a mark of like a tall rock in the way. And the reason why it doesn't erode or weather away with the surrounding is because it's much more resistant to any form of erosion or weathering than your surroundings. If it does erupt, a volcano forms. So your magma lava rises, and you have volcanoes. Pretty self-explanatory. But another way mountains can form is fold mountains. So you can draw a mountain range if you want as well, because there will be a lot of mountains. I won't go too in depth into fold mountain formations, but if you do want to go deeper, see the diagram of it, you can watch my collision plate boundary video. But remember the four key terms to use when you're describing explaining the formation of fold mountains: the compression and buckling of the crust to form synclines, and the uplifting and upfolding to form anticlines. And therefore, you have the folding of the crust, and therefore it folds up into fold mountains. Keep in mind, guys, that although the volcanoes are the strongest, the most active, and the most destructive in these types of plate boundaries, but the fold mountains and the ocean trenches, they aren't as extravagant as oceanic trenches or collision fold mountains. As you can see here, the Peru-Chilean trench or the Andes at the same area, caused by the Nazca plate subducting under the South American plate. Your ocean trench, your Peru-Chilean trench, is only 8,000 meters deep. That is very deep, but if you have watched my last video on Oceanic, it is less deeper than the Mariana Trench, which is 11,000 meters deep, and that's because the continental crust isn't as dense as an oceanic crust, so there's not too much pressure downwards to cause a really steep subduction, and therefore you don't have as deep of a trench. Fold mountains wise, if you watch my collision plate boundary video, you'll see that the Himalayas is so much more taller, at the peak at least, than the peak of the Andes, which is 6,900 meters tall. That's because when you are folding up your crust, it's generally this part that is actually crumpling up and building up the fold mountains. It's not really this part, so you don't have the contribution of two continental crusts, only one, so therefore you don't have as tall of fold mountains. So hopefully that's how you can evaluate your formations due to the differences in the crust. And that sums up most, and I think all, of oceanic continental destructive plate boundaries. And I hope to see you in the next one. Thank you.